In 1977, a professional fossil scientist looked at a 500 million year old creature and got it completely backwards. Not a small mistake either. He studied it, published on it, and kept studying it upside down for almost 15 years. Its head, he decided, was its tail. Its spikes, he decided, were legs. A trained expert whose entire job is identifying fossils got outsmarted by a worm the size of your thumb. And that's just the first animal on this list, because today we're going through 8 creatures so strange that if you saw them on a nature documentary without context, you'd assume the animation team was drunk. A dinosaur that may have broken the sound barrier with its own body. A sea creature so confusing that scientists gave it 3 different identities over 90 years. A crocodile that ran on hooves. An ape so big it was mistaken for a dragon. These aren't fictional monsters. Every single one of them was real. And by the end of this, you'll understand why the deep past is stranger than anything we could make up. Let's start with that upside-down mistake. In 1977, paleontologist Simon Conway Morris was studying fossils from a Canadian rock formation called the Burgess Shale, one of the richest windows we have into life shortly after the Cambrian explosion, the period roughly 500 million years ago when complex animal life rapidly diversified in Earth's oceans. Among the strange finds was a tiny worm-like creature covered in spikes along its back and thin tentacle-like legs underneath. He named it hallucigenia because honestly, looking at it felt like a hallucination. Here's the myth part. For years, the accepted reconstruction showed hallucigenia walking upside down, balanced on its spikes, like some kind of spiky pogo stick creature, with its actual legs waving uselessly in the air above it. It sounds absurd now, but the fossil was compressed and distorted, and there was genuinely no obvious way to tell top from bottom. Here's the evidence that flipped everything. In the early 1990s, researchers examined the fossils under an electron microscope and found tiny claws at the tips of what everyone assumed were spikes. Claws only make sense on legs that touch the ground, which meant the entire creature had been reconstructed upside down and backwards for over a decade. Once flipped the right way up, hallucigenia suddenly made sense. A small armored animal walking on soft legs, protected by spikes running along its back, like a defensive mohawk. Here's the bigger question this raises. If trained paleontologists can misread which end is up on a well-preserved fossil, how many other creatures from this period are we still misunderstanding right now? Because hallucigenia was just the beginning of the identity crisis. The Cambrian seas of 500 million years ago had an apex predator, and depending on which decade you asked a scientist about it, you'd get 3 completely different answers about what it even was. Meet Anomalocaris. In 1892, a paleontologist found an isolated fossil resembling a segmented body and assumed it belonged to a type of shrimp. Reasonable guess. Wrong guess. Then in 1911, a different researcher examined what turned out to be the creature's actual mouthparts, a circular ring of overlapping plates, and concluded it must be a jellyfish, giving it the name Peytoia. Also wrong. For decades, museums displayed these as 2 entirely separate species, a shrimp-like body fossil in one drawer and a jellyfish fossil in another. Then researchers went back to the original quarry and pieced together something nobody expected. The so-called jellyfish fossil wasn't a body at all. It was the mouth. And it belonged to the body previously misidentified as a sponge-like organism called Lagania. 2 supposedly unrelated fossils, sitting in 2 different scientific categories, were actually the same animal, one on top of the other, fossilized together. Once properly reassembled, Anomalocaris turned out to be the largest predator of its entire era, up to 1 meter long, with grasping frontal appendages and a circular mouth lined with plates for crushing prey. An actual sea monster, just one that took almost a century of scientific arguing to correctly identify. And here's what that says about the fossil record in general. Sometimes the animal isn't the mystery. The mystery is just human beings trying to assemble a puzzle when they don't know how many pieces are missing. While Anomalocaris ruled the open water, something even more unsettling was crawling along the sea floor. One of the strangest sensory systems ever recorded in an animal, extinct or otherwise. Meet Cutinitula, or creatures like it from this same era. Arthropods that could coordinate movement across over 100 pairs of legs simultaneously. Try to picture that for a second. Most of us struggle to pat our head and rub our stomach at the same time. This creature's nervous system was running the biological equivalent of playing two different pianos with two different hands at once, except the hands were dozens of legs, and the pianos were survival. These weren't small either. Some of these many-legged marine arthropods stretched over 20 centimeters, making them genuine giants of their ecosystem, and highly capable swimmers on top of that. For a long time, this raised its own separate mystery. How do you evolve that level of coordination in the first place, and why? The leading theory is straightforward once you think about it. More legs moving efficiently means more speed, more stability, and more control in a chaotic, predator-filled ocean. This wasn't excess, it was armor made of coordination. Speaking of armor, let's fast forward roughly 450 million years to a creature built like an actual military vehicle, the Ankylosaurus. You already know the basic shape, a heavily armored dinosaur covered in bony plates. But here's the part people underestimate. This thing had a genuine weapon fused to the end of its tail, a solid bone club capable of shattering the leg bones of a predator in a single strike. Living around 68 million years ago in what's now the Pacific Northwest region of North America, Ankylosaurus was so well defended that some researchers believe its very existence pushed predators toward different hunting strategies entirely. Some of the era's meat-eating dinosaurs may have shifted their attention towards smaller, easier prey simply because attacking an Ankylosaurus was a legitimate way to end your own hunting career. Nature's version of an actual armored tank, decades before humans invented the concept themselves. And that wasn't even the most extreme adaptation happening in that period. Because while some dinosaurs were doubling down on armor, others were doing something almost the opposite. They were leaving the ground entirely. Meet Quetzalcoatlus, the largest flying animal ever known to have existed. A pterosaur, meaning it wasn't technically a dinosaur, but its flying cousin. Picture something the height of a giraffe while standing on the ground, with a wingspan so wide that fully extended, it would stretch close to the length of an entire city bus. Its skull alone measured over 5 feet long, meaning if I stood next to it, the top of its head would tower somewhere around my shoulder. Just the head. Here's the part that should surprise you. Something that massive did not have a correspondingly massive brain. In fact, despite the size of the skull, evidence suggests these flying giants had comparatively modest brain capacity for their body size, which raises a fair question. How does something that big, with a brain that unremarkable, actually survive as a functioning flying predator? The honest answer is that raw size and flight efficiency mattered more than raw intelligence for a creature at the top of its ecosystem going after prey on the ground below while soaring above it, largely unbothered by anything smaller trying to compete. Now here's where we get to my personal favorite entry on this list, because it involves a completely different kind of extreme adaptation: sound. Meet Apatosaurus, the massive, long-necked herbivore you've probably seen 100 times in documentaries, usually depicted as a slow, gentle giant. Here's the part that gets left out. Some researchers have proposed that Apatosaurus and other closely related long-tailed dinosaurs could move the tip of their tail fast enough to break the sound barrier, creating an actual sonic boom similar to the crack of a bullwhip. Picture a 14-meter-long tail moving at speeds exceeding the speed of sound at the very tip. If that tail connected with anything solid, the impact wouldn't just hurt, it would be catastrophic, easily capable of shattering bone. Here's the responsible caveat, because this is genuinely debated science, not settled fact. Some researchers argue this level of stress at supersonic speed would have destroyed the tail's own structure within just a couple of strikes, meaning if this behavior existed at all, it was probably reserved purely for defense in a genuine life-or-death moment, not a casual party trick, which might also explain why later long-necked herbivores didn't evolve the same feature. The risk of literally destroying your own body in the process of using your weapon may not have been worth copying. If a sonic tail wasn't intimidating enough, imagine instead being an actual armored tank on legs, minus the tail whip, but adding something arguably worse, a built-in sledgehammer. Around 68 million years ago, in the same general region as Ankylosaurus, a group of related armored dinosaurs relied on this exact combination, a rock-solid body and a heavy blunt club for offense. Their reputation alone was apparently intimidating enough that some predators of the era are believed to have shifted their hunting grounds entirely, abandoning ground-based hunting in certain regions in favor of pursuing prey in open skies instead, which loops us right back to those giant flying reptiles we just talked about. In prehistoric ecosystems, evolution wasn't just a random walk. It was often one extreme adaptation directly causing another species to evolve an entirely different survival strategy just to avoid it. Let's shift now from armor and sound to something a little closer to home, biologically speaking. An ancient relative of ours, hiding inside a very unexpected disguise. For centuries, teeth belonging to an enormous unidentified primate were discovered across China and northern India. Chinese traditional medicine, not knowing what these teeth actually were, classified them as dragon bones, ground up and sold for centuries as a folk remedy. Northern Indian traditions had their own explanation, believing the remains belonged to ancient mythical giants. It wasn't until the 20th century that scientists identified the actual source, an extinct genus of giant ape now known as Gigantopithecus, standing an estimated 3.5 meters tall, weighing potentially several hundred kilograms, easily dwarfing even the largest modern gorilla. Here's a common misconception worth correcting directly. You'll often hear claims online that Gigantopithecus was closely related to giant pandas. That's not accurate. Genetic research has shown its closest living relative is actually the orangutan. The panda connection is purely about diet, not ancestry. Researchers found that Gigantopithecus had thick tooth enamel and heavy jaw structure, strikingly similar to a giant panda's, strongly suggesting it lived largely on tough, fibrous plant material, likely bamboo, the exact same evolutionary solution pandas independently arrived at millions of years apart. Two completely unrelated species facing a similar dietary challenge, evolving remarkably similar teeth to solve it. Nature reusing the same blueprint twice on two very different branches of the family tree. Now for one that sounds like it should be fictional but absolutely isn't. A crocodile that ran on hooves. Meet the Planocranidae, an extinct family informally nicknamed the hoofed crocodiles. Unlike every crocodile you've ever seen lounging in a river, these were fully terrestrial hunters, built with long, upright legs for running, rather than the low, sprawling gait modern crocodiles use. And instead of typical reptile claws, their toes ended in blunt, rounded structures resembling actual hooves. Some evidence even suggesting they carried their weight directly on them, much like a horse or a deer would. Their teeth were laterally compressed and serrated for slicing, built for hunting land-based mammals rather than ambushing prey near water. And some researchers believe certain members of this group may have even been capable of short bursts of running on their hind legs alone. So somewhere in the Earth's history there was a genuine, real, land-galloping, bipedal sprint-capable crocodile relative hunting mammals on solid ground. And most people have simply never heard of it because it doesn't fit the mental image we've all agreed crocodiles are supposed to have. And that brings us to our final story, the one that isn't about a fossil at all, but about a legend that ancient sailors were absolutely convinced was real. For centuries, Greek sailors feared a narrow stretch of water between Sicily and mainland Italy, a passage said to be guarded by two sea monsters, Scylla and Charybdis. Charybdis, according to the legend, was a monstrous whirlpool capable of swallowing entire ships whole. For a long time, this was treated purely as folklore, a scary bedtime story sailors told each other. Then modern science caught up, and something interesting emerged. The Strait of Messina, the real-world location tied to this legend, does have genuine powerful tidal currents, created by opposing bodies of water clashing in a narrow channel. These currents really do create dangerous localized whirlpools, treacherous enough that sailors navigating these waters for centuries treated the area with serious caution. There was never an actual sea monster, But there was a real, physical, dangerous phenomenon, one ancient people didn't have the tools to explain scientifically, so they explained it the only way they could, through story. So here's what all 8 of these stories actually have in common once you step back and look at them together. A worm that got studied upside down for over a decade. A predator that was misidentified 3 separate times across nearly a century. A dinosaur that possibly broke the sound barrier with its own tail. A crocodile that ran on hooves like a horse. An ape mistaken for a dragon for hundreds of years. None of these are exaggerations, and none of them are fiction. They're simply examples of how genuinely strange life on this planet has always been, long before humans were around to document any of it properly. We tend to assume nature follows sensible, predictable rules. Armored things stay slow. Reptiles stay low to the ground. Predators look a certain way. But the deep past keeps proving that assumption wrong, over and over again. The truth is, we've barely scratched the surface of what used to walk, swim, and crawl across this planet. And every single one of these creatures was sitting in the fossil record the entire time, waiting for someone patient enough and occasionally wrong enough to finally figure them out.